Thanks for reminding. Right, so yeah, so you need to differentiate. You should be able to differentiate between the two systems, sanitary system and sewage system. So don't confuse yourself between these two terminologies. Okay. So basically, sanitary system is the system, disposal system that you use in houses and commercial buildings, and then sewage system is from the disposal point in your house or in the buildings to the treatment facilities. Okay, so that one is called the sewage system. Right. So this is the process flow, right? The flow diagram of the sanitary and sewage system. Okay. So at this point, we still talk about these two systems together because this is the overall picture. Basically, these two systems interrelated, interconnected. Okay, it starts from your house and it ends in the environment, basically. So that is the ultimate goal of this sanitary and sewage system. Right. So as you can see from the flow diagram, it starts off with the buildings, houses, commercial buildings, right? Any buildings with occupants, basically, any buildings with occupants, and of course with toilets, right? And then basically inside all of the buildings, the sewage will be generated. Okay, so sewage will be generated by the building occupants. Right, and then from the so the sewage will be transported into the piping system, using the piping system to the treatment facilities. Okay, and then the ultimate goal of these treatment facilities is to treat the water. Okay, so basically when you open the tap water, right? So the tap the water is clean. Okay, water is clean, clear. So after you use it, after you flush it, everything, and then towards the end, before you release the water back to the environment, it should be treated. It should be clean as if possible as like what you use in the beginning. Okay, so basically it's for the protection of the environment. So the treated water is then will be channeled to the river, okay, the nearest river if there's a river nearby, or if not, or depending on the system, the water might also be just released into the ground. Okay, there are different systems for that. All right, classification of sewage. Basically, there are three classifications of sewage, different type of sewage. The first one is domestic sewage, the one that we produce in residential house, public building, commercial center, or any type of building with occupants and with toilets, right? So I guess you know what we do in the toilet, so I don't have to explain about that. And then agricultural sewage. So you need to look at the term carefully. Okay, previously it was sewerage, so this one is sewage. Basically, it means a different thing, although it sounds more or less similar. Agricultural sewage, so basically it comes from agricultural and farming activities. Okay, so it doesn't matter whether it's livestock or whether like plantation. Okay, so all those activities actually produces sewage, okay, wastewater. So before it is released to the environment, the water is released back to the environment. Okay, it has to be treated. So you cannot simply, for example, use the wash the barn or something, and then straight away just channel to the drain, then to the river. So it has to be treated. using some treatment facilities, then only it can be released to the environment. And then finally, the industrial sewage, which is generated by industrial activities. So basically the concept is the same. It's just that probably the system used is different. Okay, so the system used to treat domestic sewage is different from agricultural sewage and also different from industrial sewage, right? So, but I think for industrial sewage is very critical, okay, because if the sewage is not treated well, then it will cause what we have experienced. I think this year we twice we have experienced water shortage. Not water shortage, actually they have to cut the water because of the pollution, okay, in the river. So it's all because of the sewage from the industry, which is not treated well, okay, before it is released to the river. Okay, so you can imagine that's how critical the treatment system. Okay, that's why we have to treat the water carefully before the water can be released to the river, right? Because the effect is actually quite disastrous. So if it's not treated well. Okay, but for the purpose of today's lecture, we are just going to look into the domestic sewage. Okay, because as an architect, that's what you do. Okay, that's what your focus is on. So you just need to focus on residential houses, okay, and also buildings. Yeah? The sewage system, sanitary and sewage system for these buildings. For others type of sewage, they are mostly related to engineering. Okay, so the engineers will have to take care of those kind of sewage. Basically, this area is like is in the scope of the engineer, basically, right? Even though in the building, in the house, the piping system, everything is actually the details, everything is actually taken care of by the engineer. But as an architect, you need to know, okay, you need to know where to place all the fittings, and then where the pipe goes, and then from the house, where do you channel the water to. So you need to know all these things. So that's why in the submission drawing you have to indicate, okay, in the architectural drawing you have to indicate all these things, right? But the details of the sizes of pipes, so things like that, the flow rate of the sewage, things like that. So that one is taken care of by the engineer, right? So if you look at other type of sewages, agricultural and industrial sewage, that one is more related to engineering because the system is different. Where I mean, the engineer need to build specialized treatment facilities, okay, to treat the water, the sewage. Okay, so what is the definition of sewage? In this case, we are looking at the domestic sewage, but the definition of sewage itself is the effluent contaminated by domestic sewage. In case of domestic sewage, if effluent contaminated by domestic waste, okay, sorry, which require treatment before it can be discharged into an approved water course. Okay, so that's the definition of sewage, and it can be divided into two types. Okay, the sewage can be divided into two types. The first one is wastewater. So wastewater is effluent from sinks and basins which does not contain human or animal excreta. And the second one is soil water, which is effluent from water closets and urinals, which does not does contain human excreta. So basically there are two things. Even though maybe when you use the toilet, basically you just do everything together, right? Both things together. So, but there are two different classification. There are two different types of sewage. Okay. Okay, so now let's focus on the sanitary system. So earlier we have talked about the overall picture, sanitary system and sewerage system, and how the two system relates, okay, with each other. So now let's just focus on the detail part. And basically, as an architect, you need to know this part or this system more than you need to know the sewerage system. Okay, so that's why you need to focus on this more. Okay, so sanitary system is a system of piping within public or private premises that conveys sewage or other liquid waste to an approved point of disposal. Okay, so it doesn't matter whether it's a public building or a private premises, as long as you have a toilet in the building. Okay, like I said, in some buildings, okay, especially commercial buildings, so even in tailors, so we have like the prayer room. Okay, for Muslim we have a prayer room. So inside the prayer room we have the ablution. Okay, so that also includes the system. Okay, included in the system. So because they are in the toilet, in the prayer room, basically there's the ablution. So the ablution includes some of the piping, sanitary piping. So it also includes included in the system. So the overall system includes plumbing system and components. So plumbing basically is the piping, sewerage piping. Sometimes we call it plumbing. Sometimes we call it just piping. Joining methods between piping and fittings. So if you look at the pipes between the pipes, and then before it connects to the fittings like basin, sink, shower, the water closet. So there are some connections that need to be done. And then the sewage disposal. Okay, so it depends on the type of building that you use. Later on, I'm going to show you in details. So not all buildings use the same disposal system, sewage disposal system, right? Some use a centralized system. So another building use individual system. Okay, right. So basically that's the bigger picture of the sanitary system. So if you look at the drawing there, right? So you can see the fittings, okay, the pipes, the joints, and also the main pipe that goes to the sewage disposal. But I believe this image is taken because I took this image from the internet, and this is more likely a drawing of a building, a diagram of a building overseas. Okay, because you can see the cylinder down there. Okay, basically the cylinder, that part is actually underground, right? Basement. So if you know that, probably you have watched when you watch TV, you can see a lot of houses in Europe or in the US. They have basement. Okay, so in the Europe or US, right? So the plumbing system, and also the water supply system, the tanks, everything, they put it in the basement. So that's why basically you can see that cylinder. So that cylinder is actually for the water supply, hot and cold water supply. But have that. So just ignore that the water system supply system part. Okay, so sanitary appliances, right? So this is the first point of contact, I would say. The sanitary appliances is basically the first point that that collects the sewage. Okay, doesn't matter is the number 1 or number 2. Okay, but you need sanitary appliances, okay, to do your business basically. Okay, so the definition of that is the sanitary appliances simply means fittings used for collection and discharge of soil or waste matter. Right. As I mentioned earlier, there are 2 types of sewage. One is wastewater, another one is soil water. Okay, so basically we need to use different appliances to collect these 2 type of waste, these 2 types of sewage. It should be designed so that the fouling area is reduced to minimum and should have durable, easily clean and non-absorbent surface. You don't really have to worry about that because it is produced by the manufacturer. Okay, so basically as an architect, you just need to choose, you just need to select which design that you think suitable for the building, for your house, or for the building that you are designing. Okay, so as an architect, normally it's about the design. Okay, because most of the time the materials used would be the same. Okay, it's either ceramic, vitreous china, stainless steel, or even plastic. So your role here is basically to choose the one which is suitable, okay, for the design and suitable for the client's need, right? So there are a variety of appliances available in the market. Okay, some is very expensive, some are not so expensive, right? So depending on the budget. So if the client has more budget, and then some clients are actually very picky when it comes to the sanitary fittings, sanitary appliances. So even from my own experience, I've dealt with a client who wants to choose his own appliances. So as an architect, we just need to produce. At that time, was us just to provide the outlet point, okay. But the selection, everything is done by the client himself. Okay. All right. So similar to the type of sewage. Okay. So there are 2 types of sewage in the building. So the same goes to the type of sanitary appliances. So there are 2 types of sanitary appliances, which relates to the types of sewage. Okay, so the first one is soil appliances, okay, to carry the soil waste or carries human waste, and the other one is waste appliances, which carries other than human waste. Or in the definition of sewage, it relates to the wastewater. Okay, so you need to remember these 2 things. Right. So now I want to ask all of you. Okay, I want to get your response on whether these appliances are waste or soil appliances. Okay, it's quite obvious, but then I think some of the appliances it maybe fall under gray area lah. You don't know whether it is under soil appliances or it is under waste appliances. Okay, water closet, is it waste or soil? Anyone?
Waste.
Okay, that's so obvious. Basin? Sorry. Water closet is not waste. Okay, water closet is soil. Okay, so soil. So you need to go back here. Right, soil appliances carries human waste. Waste appliances carries other than human waste. Right, so that's the definition. So water closet is actually soil appliance. Okay, and then basin.
Waste.
Okay, bathtub.
Waste.
Okay, shower. Shower tray. Okay, shower tray. Waste, unless you unless you do your number one business there, then maybe it's a different story. Urinals.
Soil.
Okay, last one. I think this one might be a bit. This is the one that I mentioned might fall under gray area between waste and soil. But what do you think? Bidet, is it waste or soil appliance?
Waste.
Okay, it's waste, because you don't really do your business there. It's just that you clean, you clean your bag or whatever. So after you use the water closet, so it is considered as waste appliance instead of soil appliances. By the way, has all of you seen this thing before, bidet? Okay. It probably is not so common in Malaysia, but I don't know. Perhaps maybe in some of your houses you also have this thing. Okay, but it is not so common in Malaysia. It is more common in the Europe, or in the US. Okay, before we look at the details of each of the appliances, so I just want to share with you the typical sanitary fittings arrangement. Okay, so as an architect, as designer, this is one of the most important thing that you need to know, especially that relates to this topic. Okay, because I believe every time you design your building in the design studio, you will end up with toilet. Okay, so try to recall back from except for semester 1, start beginning from semester 2 until now semester 5. So every time you produce your design in your studio, you would need to design a toilet. Okay. But I'm not sure whether you know, or you already know the basic sizes of the fittings and then the clearance that you need to have inside the toilet, especially when you sit under the water closet, the length of the toilet cubicle, so things like that. Because last week I've seen some of your friends' design with some toilet cubicles, right? I'm not sure about the size of the cubicles, whether too big is okay. Not to say too big lah. If the cubicle is big, it's fine. But if it is small, then you cannot do anything, right? So that's why it need to have a minimum width. Okay, when you design a toilet cubicle, you need to actually follow the minimum requirement, right? So so basically there are many type of arrangement of sanitary fittings in the toilet, depending on the design. Okay, depending on many factors. It might be the ventilation. Okay, so where is the position of the windows for the toilet, the opening of the toilet, and then depending on the size of the toilet that you have. Okay, so if it's very small, then probably you cannot do like the first drawing. So that one is quite, I would say, it's quite lavish lah, right? You have the countertop, you have toilet, and then you have the shower area. So most of the time, especially in the apartment, you can see that the basin and the water closet is located next to each other. So the basin, water closet, and then the shower area. So that's it. And then on the right, you can see the dimension, the basic dimension of the toilet cubicle. Okay, so I would say that would be like the size is just nice. Okay, the width is 850 times the length is 1,500. Okay, 1.5 meter times 850. So that's the, I think that's the ideal dimension. So when you design the toilet cubicle in your project, right, you need to at least achieve this minimum size. If you can provide bigger than this, then that's fine, but not smaller than this. Okay, but actually, if you design a very big toilet, also is a waste. It's a waste of the floor area. Okay, so instead of using the floor area, okay, too big. I mean, the toilet is too big. Then you can make it smaller, and then you can use the floor area to do something else, no? To provide other spaces. Okay, but whatever you do in your project, try not to design a funny looking toilet. Okay, so I think if possible, try to just have a rectangular, okay, or maybe L shape if you have a lot of toilet cubicles in it. So basically the toilet is like L shape, and then with several cubicles in it. Right? But try not to design like a triangular shape, whatever shape toilet. Okay, because in the end you have to think about how. Okay, so if you have like a slanting wall, so how does the pipe is going? How do you want to actually put the pipes behind the toilet? Okay, and then whether when you put the water closet, the person who are using the toilet can actually comfortably inside the cubicle. So you have to think about all this. Right. So these are the related Uniform Building Bylaw, UBBL, which is related to water closet or WC. Okay, so essentially under the bylaw 43, right? If you look at all the definition A, B, C, and D, you can see that the minimum width, okay, the minimum size of the toilet, okay, the minimum width is actually 0.75, right? So that's the clear dimension, clear measurement inside the toilet. Okay, it's not the from center to center of the cubicle wall or center of the toilet wall. So it is a clear dimension inside the toilet. So it has to be 0.75 meter. If you have been into this kind of a toilet cubicle with this size, feel that it is actually not comfortable at all. It's very tight. So that's why it has to be, if possible, it has to be bigger than this. Okay, so that's why 0.85 is actually okay, right? To have 0.85, not too small. It's just nice. Okay, so if you read all the bylaws, A, B, C, and D, basically it talks about different type of fittings. Okay, the first one is pedestal type water closet. So the size should not be less than 0.75 meter times 1.5. The other one is if you use other than pedestal type water closet, so it has to be 1.25 times 0.75. And then the third one, the size of bathroom, right? Not less than 1.5 square meter with a width of no less than 0.75 meters. So if you design a toilet, none of the toilet wall can be shorter than 0.75. Right? So that's a bylaw. And then finally, in the case of bathroom with closet fittings, not less than 2 square meter with a width of no less than 0.75 meters. So, but for me, I think what you need to remember is that 0.75 meter. Okay, you shouldn't have any dimension in the toilet which is less than 0.75. Okay, so that's the bylaw that you need to remember. Okay, so now let's look at the different type of fittings. Okay, the first one, as you always use, okay, as we always use every day, the water closet or WC. There are two types of WC, seated and squat. But I think most of the time now we only see the seated type, which is more comfortable. There are two types of seated WC. Okay, so this is about design lah. Okay, the purpose is the same. It's just the design. Two types of seated WC. The floor mounted. Okay, the one that this is the pedestal type lah. So the one that you connect to the floor. Okay, so you can see, as you can see from this here. So there's like basically normally the bolts, the screws, the bolts are located at that point. So basically you bolt the WC to the floor, right? And then the second one is wall mounted. Okay, so this wall mounted, as you can see, it's very sleek. So if you want to have a very nice interior design, and then probably this is a good choice for you, because it appears like the WC is floating. You don't see the connection between the WC and the floor. Okay, but how it is done, then I'll show you later. Okay, so the one on the left is obviously a squat water closet, right? So normally, probably in your houses, you don't really use this kind of WC anymore. But sometimes especially in public buildings, okay, in public buildings, in the shopping malls, you would still see this kind of WC. Even in toilet, in tailors also we can see this kind of WC. Okay, and then a toilet itself, the WC itself is nothing without the flushing mechanism. Okay, so it comes hand in hand, right? So it has to, when you have a water closet, it has to come together with the flushing mechanism, right? Because without the water, okay, the waste cannot be flushed into the piping system. Okay, so even though the flushing mechanism, because it actually supplies water, okay, it can fall under later on. I'm not sure whether I think last week, right? Last week you have learned about water supply system. So this mechanism actually falls under a gray area between water supply as well as sanitary supply. Okay, because the water is supplied to that fittings, and then the fittings is actually used to flush the water closet. Right. So basically, there are two types of flushing mechanism. So the first one is the flush tank or the cistern tank, so the one that we normally use in our house. And then the second one is the flush valve. Okay, like the one you normally found in the in commercial building. Okay, even in tailors also we use this this kind of system. If you look at the images, right, for the cistern tank also there are two types, right? The one with the handle, okay, the handle that you can twist to flush the water. The second one is the push button, so normally located on top of the cistern tank itself. And then for the flush valve also there are two types. So one is the one that you have to pull, you have to push the valve down, okay, to flush. Another one is the one that you need to push the button, okay, push the button to flush the water. Okay, and if you look at the two images on the left on the cistern tank, I think some of you might be aware that there are two types of tank as well. So the one which comes together with the water closet. Okay, so it is like built-in tank with the water closet, like the one you can see on at the bottom there, the one below. And then the one on top is basically is a two-piece. Okay, so between the tank and the water closet, basically they are not attached. Okay, it can be replaced. So in case of the tank got broken or something, so you can simply replace the tank with a new one, because yeah, the parts are not connected. But the one at the bottom, if something happened to the tank, you accidentally break the tank, then you have to change the whole water closet. Okay, you have no choice. Okay, so this is the one that the one that connects to the wall, wall hung water closet. Okay, but I think some of you might be confused, whether not so sure whether sometimes I believe you have seen this kind of water closet before, especially in like hotels or maybe in a bungalow, maybe even in your own house, right? You might use this kind of water closet. Okay, so you can see the button, the push button on the wall, but you don't really see the tank, right? Okay, so basically this kind of water closet is called in-wall flush tank. Okay, so in-wall flush tank. It is part of the system. I mean the one before where you use the system tank. Okay, so basically this is a system tank as well. It's just that the tank is slightly different. Okay, the tank is different from the usual one. Sorry, can you turn off your microphone? Okay, so the in-wall flush tank, right? Basically, from the outside, you only see something like this, very slick. Okay, very slick looking. You don't see the tank, right? But usually this kind of system is hidden behind like a false wall. So this is the real wall. The white color is the real wall. You can see the wall there, but there is a false wall in front of it. Okay, which is it seems thicker. Okay, it seems thicker than the actual wall, right? Because basically the tank is hidden behind the false wall. So what goes behind the the false walls is basically something like this. So you can see that the steel frames bolted to the floor. Okay, the steel structure bolted to the floor, and perhaps also connected to the real wall behind. And the tank is actually built within the space of the false walls like this. So basically the tank is very slim, okay, very slim, that you can hide behind the wall. And the WC itself is actually bolted to the frame. Okay, so as you can see here, the WC is bolted to the frame, right? And then after that, everything is covered with maybe just like wall tiles. Okay, just use tiles. So what you can see is only the button, the flush button in front, right? And also the WC. So you don't see the frames behind the wall. Okay, so now let's look at the flush or cistern tank. Okay, the tank holds a quantity of water until the toilet is flush, at which time the water in the tank rushes down through an opening in the bottom of the tank and into the bowl, forcing waste out of the bowl and into the home drain and sewer lines. Okay, basically, I believe you already know how the flush tanks work, right? So you need water supply to supply water into the into the tank. And then as you can see from the two images below, so those are two different kind of cistern tank. So the first one on the left is the one that use handle, and the one that use the float, like a ball type float, the black color one, right? So this is the most common, I mean the most common and kind of the old-fashioned one, okay. So if you go into an old houses and then you open the tank cover, you can see the float, right? The ball float. And then other parts would be the float adjustment screw, okay, fill tube, float arm, flapper, flush valve, and the tank bolt. So basically, the tank bolt is where you connect the tank to the WC, right? Okay, so what happened when you the water is filled inside the tank, right? So the float, okay, the float would move up. So as the water fills up the tank, the float would move up. Okay, so as the float moves up, basically it would close the this water valve, okay, the fill valve, and then the water would stop coming into the tank. Okay, and then as you flush, you pull the handle, you push the handle, and then this flapper will be open, and then the water rush down to the WC, and that's it. So the other type is slightly different, where you use the push button. Okay, the other components are more or less the same. You have the flush valve, you have the float, you have the fill valve. Everything is actually the components are the same. It's just that the physical appearance of the components are different. Okay, as you can see, the float. Okay, so the usual one, the old type, the float is round shape. It's like a ball, but the one that uses the push button, the float is something like this. Okay, it's like cylinder in shape, and then it's just move up and down here. Okay, but the function is still the same. So as the float moves up, it goes up, it would close the fill valve. Okay, it will stop water from coming in. Okay, I think somewhere here. And then as you push the button here, it would open the flapper somewhere at the bottom here, and then the water rush down to the WC. Okay. Okay, so now let's look at the cistern tank, how it works. I'm not sure whether I can play the video or not.
Sir, is there
Yep.
supposed to be sound? Because we don't hear any sound.
Oh, really?
Yeah.
Wait. Wait. How do I do this?
I think you
Play.
yeah, like you turn off your presentation, then turn on.
Okay, try again. Can you hear now?
The flushing toilet.
Yeah.
Okay.
How does a gentle push of a handle create a powerful torrent and refill the tank without overflowing? 42 components work together. A robust chrome-plated handle attaches to a solid brass lever. A set of intricately designed valves control water flow inside the 2-gallon tank. A large rubber plug tightly seals a wide flush hole. When the plug lifts, water shoots down in 2.5 seconds to flush away waste through an S-shaped bend. This remarkable machine leaves a shining clean bowl in 4 seconds flat. How does a machine with so few moving parts whip up a small storm? The secret lies in its carefully designed shape. In the largest ceramics factory in Ohio, skilled craftsmen hand-carved a prototype for the molds that give the toilet its distinctive shape.
The first one, it's all done by hand, and then after that, we have a mold to reproduce it.
Make one mistake with the shape of this crucial toilet bowl, and Dave will have to start from scratch.
We're trying to get the perfect shape for the perfect flush. Everybody in the world needs a toilet, so that's what we're trying to do. First one has to be done right in order for the thousands and thousands that follow it.
A streamlined body is just the start. To keep your bathroom clean and odor-free, toilets must remove waste quickly. So how do engineers create the ideal flush? It's all down to how the water is directed inside the toilet. The flapper valve unleashes water from the tank into a channel under the seat. 20% flows through specially cut holes in the rim to rinse the sides of the toilet. The rest shoots down a high-speed pipe, rushing through the bowl as a powerful flushing jet that can take care of any business.
Okay, so the second types of appliance, second type of appliance normally found in toilet is urinals. Okay, especially in male toilet, you don't see this in the female toilet, right? So urinals, there are a few types of urinals. Okay, the most common that we see today is this bucket or bowl type, bowl urinals. It requires individual plumbing, as you can see from the image on the left. You can see most of the time you don't really see the piping, but I managed to find one image where you can see the plumbing works below the urinal itself. Okay, so that's how complicated the plumbing works look like. Right? So you need to have, for each of the toilet bowl, you need to have pipes that connects to the main discharge pipe, and then for each of the bowl, you can see that it connects there's a water supply pipe, okay, from the water tank to each of the bowl. Okay, I can hear my own voice. Can somebody turn off your microphone, please? Okay, so compared to the other type of urinals, so this type of urinal actually provide more privacy compared to the rest. Usually made of porcelain, but can also be made of plastic, metal, and even polished wood, even though I've never seen that one before. Okay, so if you look at the image on the left, you can see that from each bowl, it connects to the discharge pipe. And then for all the bowls, they are not really how to say, they are actually connected to the same pipe, same discharge pipe. Okay, and then from the same pipe it goes down to the lower level and then to the discharge pipe. So basically, the flushing mechanism for urinal is more or less similar to the WC, but compared to WC, the cistern, okay, the cistern tank, you need to push the button, okay, you need to push the handle before the water flows. But for the urinals, normally it can be automatic. So after a few seconds or few minutes, so the water will automatically flow down the bowl. Okay, and there's also the type where you need to push the button to flush the urinal. And then there's also trough urinals. Okay, this is the old type. Last time when I was in school, I can still remember. I can still this kind of urinals. We no longer use this because it doesn't provide privacy. Okay, but the only advantage of this kind of urinal is it is economical. Okay, as you only need one space. Okay, depending on the size, like if the trough urinal is big enough, it can provide enough space for eight people, 8 men, and it only requires one plumbing connection. So like the one that you can see previously, so from each of the bowl, there's plumbing connection to the discharge pipe. Okay, from each of the bowl. But here, you only need this thing, okay, and then the plumbing is actually just at this point, okay, connected to the discharge pipe. So the rest is actually just built in, like drain shape, trough or drain that allows the water to flow to that pipe, discharge pipe. And then another one is stall urinals, which is more or less similar to the bucket or bowl urinals, but it is longer or taller. It can be either half stall. Okay, half stall normally is connected to the wall, it doesn't connect to the ground, to the floor, and also the full stall supported by the floor. Okay, next is wash basin. Okay, so in architecture terms, sometimes previously probably when you go into the toilet, so everything you just call sink. Okay, as long as it is shaped like that, so you just call them sink. It is actually a sink, but then in architecture we call it basin. Okay, so the difference is normally basin is not as deep as the sink. Okay, a basin is used for washing, fitted with a water supply and drain, in which one may wash one's hand and face. So normally, basin comes together with the, if you can see from here, right, these two types of basin. There's a hole here where you can connect to the water supply. Okay, so it's like a water built-in. Okay, built-in holes where you can put the pipes, water supply pipes. But compared to the sink, so normally the sink, when you buy the sink, you only buy this rectangular thing, right? So it doesn't comes with a hole for the pipes or anything. Okay, and then you need connect the water supply separately. Okay, so for the basin, you can just put the tap, okay, on top of the basin. But then for the sink, so you need to make a different connection. So either it coming from the wall, or the supply pipe coming from the, in this case, it's like a countertop like this, and then just at the back of the countertop. Okay. So typically made of ceramic, concrete, glass, or marble, okay, depending on your design, whether which one that you like. And then sink is also, if you look at the definition, they are both called basin. Okay, but the only difference is the usage. Okay, the usage, and also not really particularly on the shape, but more on the usage. So sink is a basin used for holding water for washing, right? So that's why normally it's deeper. So it's deeper than the basin, typically used in the kitchen. And it is usually made of stainless steel and composite materials. Okay, bathtub. So a container for holding person may bathe, typically made of thermoform acrylic, porcelain, fiberglass, reinforced polyester, and so on. Okay. I think in Malaysia we don't really, maybe in bungalows you might use a bathtub, but in normal houses like in apartments, okay, terrace houses, you don't really use a bathtub. Okay, shower tray. Shower tray is also probably not so commonly found. Depends. Okay, some bungalows might use this shower tray because it can come in very sleek design, very nice design. But the purpose is actually to ensure that water flows where it's supposed to flow. Right. So as you take your shower, so you need to make sure that the water goes to that opening on the floor. Okay, to the water the floor trap, something like that. Most of the time, especially in apartments, there is no shower tray. It's just that shower area with normal floor tile finish, and that's it. So that one is not really called shower tray because there is no tray at the bottom. Okay, so the shower tray is this thing, the one that you can see at the bottom there, right? So normally the material is different from the floor finish. Okay, the floor finish normally is made of tiles, ceramic tiles, but the shower tray itself is made of porcelain. Okay, something like the same material as the water closet. Okay, bidet, this is the one that I've shown earlier. So it's a bowl or receptacle designed to be set on for the purpose of washing your bag after using the WC. Typically includes water supply and a drainage opening. Okay, so I hope you don't use it for basin, right? So which is because it's not how it is used. It is installed a separate unit in the bathroom beside the toilet, shower and sink, which users have to straddle. So you have to something like sitting on this thing. Okay, same material as WC, and commonly used in European countries. But nowadays, instead of because I think this is some kind of a waste of money, right? Because you have to buy two of this thing, this WC, and I think the price, the cost is more or less the same. Okay, the size is also more or less the same. It requires more space, and then you need to spend more, okay, to provide this thing. So I think a more economical solution is to use the hand spray. So normally in a toilet, especially in Malaysia, instead of providing this bidet, so you just use the hand spray. And I think in commercial buildings, sometimes the bidet is like built in. Okay, so instead of putting the hand spray, you have the bidet inside the water supply inside the WC itself. Okay, so enough of the appliances, okay, the main appliances. So the second part, the other part is basically the traps, okay, the plumbing traps. What happened after or below the appliances, okay. So you install the appliances on the wall or on the floor, and then before it is connected to the discharge pipe. So you need to have this thing called plumbing traps. So the plumbing trap is generally fittings between the soil or waste appliances and the sanitary or sewage piping that prevent foul gases or smell coming from the pipes. Right. So this is, for example, this is your basin, or just imagine that this is if this is the WC, then maybe here is the floor level. Okay. So below the appliances, you put the trap, okay, like this. Then only after the trap, it is connected to the discharge pipe. Okay, discharge sanitary pipes or discharge pipe. Right. It traps or it retains a small quantity of water from the discharge of fitting or fixture outlet as a barrier. So this water, right, is trapped inside this part here. Okay, so after you use the sink or the basin or the WC, so there would be a small quantity of water trapped here. At the same time, it actually blocks the gas, the foul gases from entering the house. Okay, so you can flush the water out to the discharge pipe or sanitary pipe, but this water here actually blocks this the foul smell, okay, from entering the house. Okay, if there is no water trap in this, if let's say that you don't provide this trap, for example, from the appliance, straight away it goes to the discharge pipe, okay, like this. Right, then your toilet will be very smelly. Okay, and it also happens if you don't use, let's say you leave your house for a very long time, maybe a few months or even few years, and then because of the evaporation and things like that, the water inside the trap might be gone, okay, after a while. And then after that, you might find that after you leave your house for a very long time, then the smell of the toilet is going to be I mean it's going to be smelly because there's no water inside the trap anymore to prevent the smell from coming in. Okay, made of PVC, galvanized iron, and stainless steel. All right, so there are a few types of plumbing traps with the different. You normally place at different places, different area, and also serve different function. Those which are connected to sanitary appliances are normally the P trap, S trap, Q trap, okay, and also the bottle trap. And then the other type of traps are the floor trap, gully trap, and also grease trap. Okay. So P trap, if you look at carefully, the shape is like a P. It forms a P shape like this. Okay. So you can see the P shape. Okay. And then the pipe typically go through the wall behind the fixture or before exiting through the floor. Okay. So from here, the pipe connects to the discharge pipe, which is inside the wall. You cannot see it, but sometimes if let's say the distance of this pipe is quite long, which is normally is not the case, you can connect to like another pipe, and then the pipe can goes in front of the wall depending on the situation, but most of the time it's like this. So after you put the P trap like this, it connects to the wall, and then the discharge pipe is actually behind the wall. You cannot see it. So it is installed under the sink in the bathroom and kitchen to trap debris that has drained from the sink and prevents it from forming a clog, and also is in water closet and soil pipes. Okay, so even though the in the WC, right, this whole thing is actually built in, right? So it comes together. This whole thing comes together. But there are actually two types of WC that you can choose from. So this type of WC is called the P trap WC with P trap, where the piping actually goes behind like this. So the discharge pipe is going to be behind here. You need to have the discharge pipe behind here, either behind the wall. It cannot go in the wall because the it cannot goes inside the wall because the usually the sewage pipe, okay, for the soil pipe is bigger than the waste pipe. So from here you can see that the waste pipe is actually quite small, and you can actually hide it inside the wall. Okay, you can actually knock the brick a bit, and then you put the pipe inside the wall, and then you close with tiles. You cannot see the pipes. But for the soil pipe, because it's quite big, you know that the brick wall thickness is about 150 mm. So the pipe itself is already like almost 100 mm. So you only have like 50 mm, which you cannot cover. So in the end, it either goes behind the wall. So let's say you have a wall here. So the pipe would go behind the wall. So meaning that you can see the pipe behind the wall, or the other type is which I'm going to show afterwards, is the S type, where the pipe actually goes down, where you cannot see from the from this level. Okay, so this is the S trap. Again, because the shape looks like an S, it goes down through the cabinet floor almost directly under the sink. So if you have a sink or basin on top here, okay, so you put something like this. So you have the S trap, and then it goes down like this. It goes down to the floor. So the P trap goes to the wall, okay, goes inside the wall, but the S trap goes under the floor. Typically used for fixing water closet in toilets and sometimes under the sink in the kitchen. So most of the time it is used for this S trap water closet. For sink, normally we use P trap. Okay. In some countries, it is actually the use of this S trap is prohibited, as this kind of trap easily siphon dry with each use, and the water seal no longer exists. Because just imagine that when you flush the water in, and instead of it has to retain a small quantity of water here, but it ends up flushing the whole thing outside the pipe because of the siphon effect. So in the end, there's no longer water seal here, and because of that, the smell after you use the toilet, the smell can actually gets into the toilet. So not only the smell, it's actually the bacteria, everything. Okay, so that's why in some countries it is banned. Okay, so this is the S trap WC, where you can see the difference between this one and the previous one. So the previous one, the P trap WC, the pipe goes to the wall, and then the S trap, the pipe goes down to the floor. Okay. So as an architect, basically you need to know which one to use, and when to use the P trap WC and when to use the S trap WC. I'm going to show you what's the effect if you choose the wrong type of WC. Yeah? Okay, the other type of plumbing trap is bottle trap. Yeah, so this is very common, especially for basin. Okay, in basin that used in the toilet. You can see this thing below the basin. Most of the time, it is visible. Okay, you can see the trap, right? But this is quite unique compared to the two traps, the P trap and S trap, where it's quite straightforward. You can see that after you flush, okay, and then the water will be retained here, okay, and then so the foul smell cannot enter, okay, because of this water, because of the water, so the foul smell cannot enter. But for bottle trap, how it works is actually quite different. In another aspect, it works more or less similar to P trap, where the pipe goes behind the wall, inside the wall or behind the wall. Okay, but the bottle trap, what happened inside the bottle trap is something like this. Okay, this is the basin, and then there is a small like pipe. You can see the dotted lines, basically the pipe from the basin. Okay, and then the outer line is basically the bottle trap itself. So as you use the basin or sink, so the water would flow from the pipe, okay, and then to the side, into the bottle, and then to the discharge pipe. And it will actually retain small amount of water here, okay, but the gas cannot penetrate, cannot enter, because to enter it has to go this way. Okay, it has to go from here to here, okay, to get to the house. But because there's a water seal there, so then the gas cannot enter. Right? But if there is no tube or pipe inside here, if there is no pipe, there's no tube, then the water seal cannot do anything. So the gas can simply can easily goes up to the basin. Okay. Okay. The next one is Q trap. Okay, not so commonly used under water closet in the toilet. Okay, but like other places, like I said, it's not commonly used. But here from this water closet, the WC, you can see slightly different. Okay, the P trap water closet is like 90 degrees. The pipe angle is 90 degrees. Okay, it goes to the wall like that. So the S trap is straightway go down to the floor. But for the Q trap, it is like that. Okay, because the shape is like Q lah. So Q is like that, right? So it's like this. So it's about 45-degree angle. Okay, but not so commonly used. I don't know. I've never seen this before, but it exists. So I'm not sure whether in Malaysia we have ever used this kind of WC or not. Okay, almost similar to S-trap. The function is almost similar. So the way it retains water, almost similar. But it is only used in upper story, okay, other than ground floor. It cannot be used in the on the ground floor. Okay, the next type of trap is the floor trap, or sometimes we call it floor drain. Okay, it's a plumbing fixtures installed in the floor of a structure to remove any standing water near it. Okay, I think it's quite straightforward. You know how it works. Typically collects water, wastewater from wash basin, shower, sink, bathroom floor, and so on. It usually round, but can also be square or rectangular. The floor trap is normally connected to a P trap under the floor, as you can see here from the image. And some floor traps are anti-insect with basically water seal. So you can see if you look closely. So after it collects the water from the floor, it will provide like a water seal around the trap, okay, that prevent like cockroaches or ants from coming in from the pipe itself. Okay. Okay. So as you can see from this diagram, right, so this is the floor trap itself. Okay, so if there's water on the floor, so the water would flow directly into the water to the floor trap or floor drain. But at the same time, the other waste appliances like the basin, bathtub, this shower tray also connects to that floor trap, right? So meaning that from those waste appliances, they are not directly connected to the discharge pipe, but it depends. Sometimes it connects to the trap first. Okay, so all the water connects to the trap, then only to the discharge pipe. Okay, so from the appliances, you can see some of the appliances has the trap like this one, S trap or P trap for the basin, but for the bathtub and for the shower tray, there is no trap at that appliances itself, but the trap is actually provided here below the floor trap. It can be that way as well. So again, as an architect, your role is actually to choose the most suitable design, because there are so many designs of interesting, nice design of floor traps in the market. So you need to choose wisely which one to be used. Okay, gully trap. So the function is the same as the other, like P trap, S trap, or bottle trap. Is actually to prevent the foul gases entering into the building by providing water seal. But the position, the location of where the gully trap is placed is actually outside. Normally, it's outside the building. before connecting to the sewage, external sewerage line. Okay, so it collects water, wastewater from kitchen, sink, wash basin, bath, and wash area. Okay, so gully trap only deals with wastewater, right? So the soil part is connected directly to the sewage line. It doesn't go to this gully trap, right? I'm not sure whether you have seen this gully trap before, but normally if you live in a bungalow or terrace house, not so sure. But normally, if you live in a bungalow, then behind the kitchen you can this gully trap. So that is how it is installed from this section view. So basically, you already have the P trap inside the sink. Okay, but then inside the sink or under the appliances, but there is additional trap. Okay, gully trap here, additional trap that prevents the fall smell coming into the building. Okay, this is how it looks like before installation. Okay, and then another one is grease trap. Okay, grease trap is only used for restaurants, hotels, colleges, food manufacturers, and so on. If you have hot food preparation, so if you need to fry things in a large quantity, like if it's a small quantity like in a house, you don't really need it. But for your final project, because you have cafe, right? So you have cafe, probably you need to provide a small grease trap. Okay, you need to provide a small grease trap. So in the diagram later on, you need to show that in the diagram, the sewage or the wastewater flows, especially from the kitchen, flows to the grease trap before it is being discharged to the sewer line. Right, so you can see that normally this is like industrial sink, okay, which is not installed in the countertop or something. So it comes like this. Right? So normally it's used in the restaurant and central kitchen, things like that. So instead of you can see at the bottom is the same, more or less the same as the normal sink. Okay, you have the pipes, but here basically there is no P trap or S trap because the trap is here. Okay, the grease trap. You have a huge grease trap, so you don't need to have S trap or P trap below the sink. So straight away from the sink, it connects to the grease trap. But then there's a miracle happen in the grease trap. Okay, so this is how it works. So the water flows from the inlet. Okay, and then there's a solid basket with filter screen, captures food particles. Okay, and then it flows to this side where the so the grease and the air entrained air goes upwards, okay, assisting the grease and water separation. And then the clean water, it comes from not so clean lah, but then you can say that there's no grease, there's no fat solids in the water before it is discharged to the outlet lah, okay, to the sewage line. Okay, another part of the sanitary system is the drainage or discharge pipe. Okay, so after the fittings, okay, after the traps, everything, so the sewage actually flows to the discharge pipe. Okay, which is the discharge pipe is actually the pipe that carries soil and waste water from sanitary appliances to the disposal point until the bottom here, and then at the bottom it will be connected to another pipe that goes to the sewage treatment and so on. It consists of a single stack. So stack is actually a pipe. So a different name for a pipe. Okay. So this is the stack. Okay, branching and vent pipe. Okay, branching is from the pipe itself, branches to the appliances. Okay, and then vent pipe is connected. At the bottom is the discharge pipe, the one that brings the sewage to the disposal. Discharge is called the discharge pipe, but the pipe that goes up to the roof is called the vent pipe. So single stack pipe is installed vertically to ease discharge of soil and wastewater. so it has to be vertical, as you can see here. And branching pipe is connected from the sanitary fitting with single stack pipe. So this is the branching, okay. And then vent pipe to release compressed air. Okay, foul air, compressed air, everything will be released from this vent pipe. So basically there's opening right on top of the vent pipe that releases the foul smell, the gases, everything. And there are three, basically there are more than three, but then the most common would be three system employed in the installation of soil and waste water discharge pipe. The first one is single stack system. So I think you need to remember all these three systems. What are the differences between these three systems? Single stack system, single pipe system, and dual pipe system. Okay, so I've mentioned, as I've mentioned, the vent pipe supplies fresh air to plumbing fixture and also prevents gases from entering the house. Okay, so how it works, basically it helps the system, sewage system, move water through the discharge pipes each time a toilet is flushed or a sink is drained. Okay, so if there is no opening at the vent pipe, so you won't be able to flush, okay, because it would create like a vacuum effect inside the pipe. So in the end, the water would not flow down. You won't be able to flush the toilet. So when there is opening on top of the vent pipe, basically it will provide air into the pipe, and as a result, you can flush the toilet properly. And at the same time, as I mentioned, it prevents sewer gases from entering the home, right? So because you already have the traps, okay, the P trap, S trap below the appliances, so the smell or the foul smell cannot enter from the appliances. So end up the foul smell, gases, everything will go up and be released into the atmosphere, to the environment. Okay, the pipe is located on roof, extended between 300 to 450 mm. So if you look at maybe if right now you are sitting next to a window, then you can see your neighbor's house. You can see that there's a pipe, okay, extending above the roof about 300 or 450 mm. Away from windows or air conditioning units, so that the fumes can easily dissipate. So if you have a pitched roof, then there's no problem, because obviously it's going to be far from the windows and aircon. But if you have a flat roof, then that might be a problem. If you have a flat roof and then next to the pipe you have something else, maybe a door or window that opens up to the flat roof, then there's a problem. So you need to make sure that the pipe is actually reasonably far from any opening, okay, to prevent the backflow of air. So just imagine that if there's wind blowing into the over the pipe, the vent pipe, and then into the house. So you don't want that to happen. So vent cowl is placed at the end of the vent pipe to protect the pipe opening from rain and unwanted debris, and at the same time letting the air from the pipe to go out. Okay, so this is a single stack system. So you need to remember the differences between all these three systems. Single stack system. So you only have one discharge pipe, and the same pipe connects to the vent pipe. So that's why it is called a single stack. Okay, single stack. So you only have one pipe for everything, for discharge as well as for the vent pipe. But it has to be, the diameter is larger, about 100 mm. Compared to the other two types of system where it can be smaller. Your discharge from sanitary fittings are transferred into the stack pipe and drained into underground drainage pipe, and is suitable for multi-story buildings. But the sanitary fittings need to be installed near the pipe, okay, to reduce the length of branching pipes and minimize the sound of flow in the pipe. So sometimes I think in tailors also it's the same, right? So sometimes you can hear like water flowing from the upper floor. Okay, you are sitting in a room, but you can hear water flowing from the upper floor, which is not so pleasant to hear, right? especially if you're eating at the low level and then you hear like water flow from, you know that it's from toilet, so it's not a pleasant thing to hear. Okay, so you can see the how the fittings are installed. Okay, you can see all the fittings and then the sizes, the different sizes of pipes, okay, connecting to the stack, right? And then you can see here there's a maximum dimension. This is 3 meter, maximum 3 meter from the appliances to the stack pipe. Okay, so it has to be this one also same 3 meter, and this one is 6 meter, depending on the size of pipes. Because for the WC the pipe is bigger, then the distance from the stack pipe to the fittings can be bigger. This is 6 meter. But for the sink, basin, and bathtub, the pipes size is smaller than the WC. Then you cannot have a very long dimension. I mean, sorry, the pipe cannot be too long. So maximum is 3 meter. Okay, for the bathtub, depending on the connection. The second one is a single pipe system. So single pipe system, don't get yourself confused because this one is single stack, this one is single pipe. So what you need to remember is single stack, everything is at the same pipe, happening on the same pipe. Vent pipe and sewage pipe, discharge pipe is actually the same. But single pipe isn't, even though the name is single pipe, but it doesn't mean you have only one pipe. So single pipe means you have one pipe for discharge and one pipe for vent, okay, ventilation. So basically you have 2 pipes. Looking from the diagram, you can see there are 2 pipes, but instead of having these 2 pipes, but in the end, at the bottom, these 2 pipes will connect. Basically, the vent pipe would connect to the discharge pipe at the bottom here. Okay, but going up, basically you can see 2 separate pipes for ventilation and also for the discharge. There are 2 options whether you have 2 separate vent pipe for the discharge pipe and the vent pipe itself. You can have 2 vent cowl on top, or you can also just connect the vent pipe to the discharge pipe and you only have 1 vent cowl on top. So it depends. Okay, but in the end, basically you have 2 pipes in this system. So it is economical if all sanitary fittings are grouped near to the discharge pipe. Okay, if not, then maybe it's not too economical. So another one, the final one is dual pipe system. So in dual pipe system, basically you would have 4 pipes. Okay, 2 pipes for discharge, 1 for waste and 1 for soil, and another 2 pipes for vent. Okay, so 1 ventilation pipe for soil pipe, so 1 vent pipe for waste pipe, right? And they actually don't connect. They're not connected at the bottom. So as you can see at the bottom here, below the ground floor, so the soil pipe goes directly to the sewer line, and then the waste pipe, it goes to this gully trap, and then only to the waste pipe. But they are not connected. Okay, until at the main point, at the collection point. But the same goes to the single pipe system. So on top, you have 2 options, whether you have 2 different pipe. One is for vent, and then another pipe, the soil pipe, goes up to the roof, or the vent pipe can actually bend and connect to the soil stack, and you only have one here, and then another one over here for vent. Okay, suitable when the waste fittings are located far from the soil fitting. Okay, so you can have 2 separate systems, okay, for this. But this is the best and most improved system of plumbing because it provides 2 different pipes for waste and also for soil. In comparison between these three different systems. Okay, I think you can read that later on. Okay. Okay, so now let's look at the piping. Piping, because piping is also part of the sanitary system. So this is how the pipe might look like. Okay, so there are two possibilities in plumbing, whether you expose or you enclose the piping system. So in this case, you can see that the pipes is quite obvious. You can see the pipes, but I'm not sure whether this is plumbing pipes or it might be the rainwater pipes. If rainwater pipes, maybe it's not so. I mean, it's still okay, but then if it is a discharge pipe, then maybe it's not so pleasant. Okay, but this is how you see it internally, right? This is how you see. You either can see the pipes, okay, like this, or you can hide it, right? So the choice is yours. I don't know. Maybe some people they like to expose. Even in tailors, so you can clearly see the pipes, especially in the toilet. But that's fine because all the pipes are in the toilet. Okay, but just imagine something like this. You are in the living room, and then you can see all the pipes above you. And then what happens if there's leakage, right? So the pipe is leaking, and then the water drops on your head. So things like that. So there's no right or wrong. It depends. Sometimes some clients they like to have this exposed pipe. Okay, and with the exposed pipe also you can do a lot of things. Okay, like this one you can color, you can blend in with the interior design of the toilet, things like that. Okay, but I think externally it might look very unpleasant. Okay, for me it's an eyesore lah. I don't like to see this kind of piping, exposed piping from the outside. Right? I think a lot of old houses in Malaysia have this kind of piping. Okay, so the pipes are actually behind the wall. Okay, exposed from the outside. Like this. Okay, I think this is the worst. The bottom right here. So this is the worst. You can see all the pipes. But I don't know. Maybe you can do something to make it. I mean, to make it nice. Okay, using different color or whatever. Right. And it also might be contributed by improper selection of sanitary appliances. Okay. So, like I mentioned earlier, it's very important for you to choose, especially when it comes to water closet. It's very important for you to choose the appropriate one, whether it's P type water closet or S type. Okay, so this might happen if you choose P type water closet. Okay, because the wall, I mean, as I've shown in the earlier slide. So the pipe goes to the wall and then behind the wall. So if your toilet is connected to the exterior wall, so the pipe will go behind the wall like this, and it will be exposed from the outside. So that's how you get this kind of pipes. So same goes to the other things lah here. Some of this might be the vent pipe. Okay, you can see this is the vent pipe. Okay, connected to the waste pipe here. This is just the soil pipe. Okay, so things like that. But if you choose correctly, instead of using the P-trap water closet here, you use the S-trap. So imagine that inside the toilet, you use the S-trap. So the pipe actually goes down, but still inside your house. You cannot see it from the outside. Okay, so it's inside, but this is what's going to happen when it is inside the house. This is what's going to happen. You can see the pipe inside the house. Okay, but at least when people look at your house from outside, it's okay. Okay, they don't see the pipe. Only you can see the pipe inside, but you can do something to hide the pipe. Okay, so what can be done? If it's just a water supply pipe, okay lah, you can paint the water, you can paint the pipe like this, okay, which is quite nice, right? And not so unpleasant, okay. But I don't think if it's a waste pipe or soil pipe, even if you paint the pipe also, it is still unpleasant because it's quite big. It's quite big, and then you know what flows inside the pipe. So when it is exposed outside, you can do something like this. You can make a box. Okay, we call it box up using like plaster. Okay, the material is like plaster ceiling, a cement board. Okay, a plaster board or cement board, and then you cover up the pipes. I don't think this is a sewage pipe. Like this is something like a gas pipe or something. But it's the same lah. How you can do it is the same. So just imagine that this is a sewage pipe, sanitary pipes, and you cover everything with box like this to cover up, so you don't see the pipes, and people might think that it is some kind of column or something. Okay, because it's it protruded from the wall, so people might think that it's a column. And another thing you can do is to have this kind of louvers. Okay, so you can see the pipes inside here, right? But the simple way, I believe there's a window, toilet window here behind the louvers. Okay, a simple way to cover the pipes are using this louvers. Okay, I think it's 10 o'clock already, so I'm just going to continue with the lecture, and then after that I'm going to have this general tutorial with everyone. Okay, so on how to do the sanitary layout plan and diagram, right? So just bear with me. And then on the inside of the toilet, if the pipe is on the floor, okay, like this, okay, similar to this one, okay, so this kind of pipe which is on the floor. So this is a P-trap toilet. You can see that this is a P-trap water closet. So and then you have a pipe, and the pipe is inside the toilet at the floor level. What you can do is to have a box up like this, cover up with tiles. Okay, maybe you plaster first, or you put like a steel frame, and then you put the tiles, okay, to cover that pipes. And the most common thing that we can see is like this. So normally the pipe is located at the corner of the toilet like this. So even in toilets also you can see, you can't really see it, but actually if you still remember lah, the toilet in tailors, right? So there's like a compartment at the end of the near the window, the wall, the external wall. So where you have that squat toilet, you notice or not, this is quite smaller than the other two cubicles, and inside that basically it's actually a what they call it, a riser. Okay, it's a riser. Sorry, there's a pipe. Okay, there's a pipe behind that, but it is covered. It's covered with a louvered door or something like that. Okay, but if it happens in your house, so initially this is how it looks like. You have the pipes. This is the discharge pipe, and then this is the, I don't know, maybe this is the vent pipe, right? From the floor below going up. But what can be done with this pipe is to box up like this. Okay, cover up with like maybe cement board or something. Okay, and then in the end you put the tiles, the wall tiles, to cover up, because if not then the wall might get wet, right? It will ruin everything. So you need to cover with tiles, right? But you won't see the pipe. Yeah, you won't see the pipe behind it. Okay, so this is a good way or clever way to hide the discharge pipe. Okay. So sometimes you can see that the box up is actually quite small. Okay, Even if you look at your toilet now, also is okay. So the other part of the sanitary system is the manhole and inspection chamber. Okay, so these two things are, I mean, the purpose is more or less the same, right? It's just the difference is just the maybe the size, and yeah, the difference is mainly the size. Okay, so what are manholes and inspection chamber is basically spaces or holes constructed at a particular location above the drainage pipe and have a removable cover. Okay, so basically in the toilet, from the discharge pipe in the toilet, it goes to the manhole and the inspection chamber. Okay, before it goes to the treatment facilities. Okay, so it can be rectangular or it can be cylindrical in shape. It can be made of UPVC. The body itself can be made of UPVC, precast concrete, bricks with concrete floor. So the first one, this is a brick manhole with the concrete floor. And then this is the precast concrete manhole or inspection chamber. So this is the UPVC type, right? Where do you put this manhole or inspection chamber? Basically, the possible locations at significant changes in direction. Okay, for example, like maybe at first the pipe goes it bends to the left or to the right. So before it bends, you need to put that inspection chamber or manhole. Okay, before the change of direction. At significant changes in gradient, especially if you live on top of a hill or something. So the water pipe flows from your house, okay, to the first point, and then from the second point there is a significant change in the gradient. Then you need to put another manhole or inspection chamber. And then near to or at the head of a drain, the one is different. The one is normally for drainage, for stormwater, water drain, where the drain or the piping changes in size, right? And then at junctions, as long as on long straight runs. Okay, nowadays most of the manhole covers are cylindrical in shape, a round shape. Okay, the reason why is because like this. If it's round shape, then there's no way it might fall down into the manhole itself and hitting the people working in the manhole. But if it is rectangular in shape, if you rotate it in certain direction and it happens to be like this, okay, it might fall down into the hole and then hitting the workers working. So if you don't know, basically the this manhole cover is actually very heavy. Okay, so it might kill people who work inside the manhole. Okay, the purpose or the function of the manhole and inspection chamber. So basically, there are four main function or main purposes. The first one is of inspection, just to check whether there's any leakage, right, or breakage of pipes, anything, or blockage inside the pipe. If for manhole, basically someone can actually get into the hole and then to do the inspection. But for inspection chamber, because the size is smaller, then camera can be used. So camera can be used to check, okay, to inspect the pipe. Then ease of cleaning, right? To clean whatever blockage or anything inside, and then ease of testing. So basically, what you can see from the image is smoke testing. So basically, smoke testing is smoke test is basically to check whether there is a breakage in the pipe. So if there is a breakage, you can see that instead of the smoke coming up from the manhole cover, the smoke might come up from the road surface. Okay, so that's for testing. and ease of sampling. Okay, maybe for some reason they want to sample the water inside the manhole, something like that. Okay, the difference between manhole and inspection chamber: manhole is larger than inspection chamber. Inspection chamber is smaller than the manhole. Okay, with depth less than 1 meter. Manhole allows physical entrance and therefore has sufficient space for a person to gain access. Okay, so manhole allows a person to get into the hole, but inspection chamber does not permit physical entrance into the drain. So basically, just for observation, right? Surface observation. So just open the cover, and then observe from the ground level. Right, and then the construction of the manhole is leakage free. So inner wall surface is plastered with mortar mixed with waterproof materials. Okay, this is the thing that you would be doing for the assignment, and as I mentioned earlier, when you go out and work in the industry, okay, after semester 6, after you graduated, you work in the industry. This is one of the things that you might be doing. So instead of just designing a house, a building, or whatever, especially when it comes to the submission drawing submission to the local authority, you need to submit a working drawing. We call it submission drawing. So on the drawing itself, you need to provide this diagrammatic layout, sanitary layout, right? Not sewerage, but just sanitary, because sewerage is mainly the role of the civil engineer and the mechanic. I think civil engineer, right, deals with the sewerage system. But as an architect, you need to design. You need to determine the position of all the fittings, appliances, and then you need to decide where the sewage flows. Okay, from all the appliances, where does it flow to? Okay, so from here you can see this is the plan. There are two things that you need to do: the plan, okay, as well as the diagram. Right, so later on for the tutorial, I'm going to show you how you can produce this. It's quite straightforward, basically. But the first thing you need to do is to have your toilet design, toilet layout. So where are you going to put the WC? Where are you going to put the basin, right? The floor trap, and then the kitchen, where you put the kitchen sink, and then normally in the kitchen you're gonna have floor trap as well. And then from all the appliances, you just need to draw lines to the nearest discharge pipe. So you just imagine, right, from here that there's a pipe, vertical pipe here, that goes up to the roof as a vent pipe, but it goes down as a discharge pipe. So all these appliances here connects to that pipe. Okay, because there are two toilets here in the kitchen at different location. Okay, so at the back here, all the pipe goes to one pipe. All the pipe from the appliances goes to one pipe, and then from here it connects to the other pipe in front, okay, where the other appliances connect to, okay, from kitchen, and then from the second bathroom. So all the pipe connects to this discharge pipe, and then at the same time everything is discharged outside the house. Okay, because this is I believe this is maybe a semi D house or something. Okay, and then normally for a modern development, okay, residential development, it is a centralized system where all the sewage is delivered or disposed at the sewerage treatment plant, okay, the sewage treatment facility, which is not within the house compound itself. Okay, so this is the ground floor, and if you have 2-3 levels, basically at every level, wherever you have toilet or any floor trap or whatever, so you need to provide the plan. So for the first, this is the first floor. You can see from the toilet, but from the first floor it doesn't go to the pipe here yet, right? Because what happened is basically from the first floor, everything goes to one pipe. If you can see, there's a pipe here within this wall. So there's a pipe at this point. So all the waste goes to that pipe, and then from that pipe, it goes down to the ground level. So this is the pipe at the ground level. And then from that ground level, only it goes to the discharge pipe, right? So you need to imagine that there's a vertical pipe here from the first floor. It bring the water down to the ground floor. From the ground floor, then only it bring the water to the sewage to the discharge pipe. Okay, so the same goes to the back here. So the toilet, there are two toilets at the back here. So for this toilet, all the waste is connected to this pipe inside the wall. And then on the ground floor, you can see that this is the wall here. This is the pipe inside the wall here. So whatever you show on the first floor, right, whatever pipe you have on the vertical pipe you have on the first floor, you need to have it on the ground floor as well. Then only on the ground floor, you connect that pipe to the discharge pipe here. Okay, so this is another one. Also from this toilet, from the appliances, it goes to this vertical pipe inside the wall, and then on the ground you can see that these two pipes here connects to the main discharge pipe. Right. So basically, that's what you need to do, even for the assignment, as well as in the future when you work in the industry. You need to provide this. You need to show all this, okay, on the submission plan. Okay. This is another example, but this one is for, I believe this is for a bungalow. This one is that there's no manhole here. So straight away from the house, it goes to the main sewer line and then to the treatment facility. But this one is an example of a layout for a bungalow. So where you have the toilet at different location, and this is ground floor plan. And then from every toilet, because the land is huge, okay, because the land is yours, so you can have the manhole, and because the building is big and the toilet is located at different location, so basically you can provide the manhole. So for this toilet, the waste and soil pipe goes to this manhole, and then from this manhole, this is what I meant earlier, because there's a change in direction of the flow from here to here. That's why you need to provide a manhole at this corner. Then from here to here, change of direction again. So that's why you need to provide manhole. And also this is like a junction, so where you combine this pipe and this pipe. Okay. And for this toilet, it connects to this manhole, and then from this manhole to another. Sometimes even if the sewer line is straight like this, but at certain point, okay, if it's too long, then you need to provide one manhole in between, okay, for inspection. This is like a not really a manhole, it's a inspection chamber, okay, where you can inspect anything. And then from there, you connect to, because change of direction, so you need to provide another one. And because there is a kitchen here, so basically the waste from the kitchen, from here you can see that from the kitchen it goes to this floor trap, and then from the floor trap there is a pipe outside here, which might be the gully trap. Okay, it might be because there is a kitchen here, so that might be a gully trap here, and then from the gully trap, so basically from the kitchen it doesn't connect directly to the manhole. Okay, so it doesn't connect directly to the manhole, it connects to the gully trap. Another possibility is basically this pipe, similar to this one and this one, basically carries the waste from the upper level. If there's another level, I think that there's another level, because you can see there's a staircase here. So there's a first floor, and then the toilet from the first floor. Okay, the pipes from the toilet on the first floor goes outside the wall, and then from there it connects to the manhole. Okay. So same goes to all this at the toilet. And then change of direction, you provide one manhole, and then because this is like a junction, so you provide another manhole, and then this is the last point before discharge to. So there are two options here. Sometimes, normally, if a bungalow located far from, maybe located at suburban or rural area, sometimes we tend to provide septic tank. Okay, meaning that the waste will be discharged to the septic tank, and there is no sewage treatment plant. But if it is located in a town area, right, it's in an urban area, then it might be discharged to the sewage treatment plant. So this is another thing that you need to do for the assignment. Basically, after you provide the plan, you need to draw the schematic diagram, right? But as I mentioned to the students in my group last week, you can do this before you finalize your floor plan. I understand that after the interim, you need to change your floor plans, right? You need to do major change to your floor plan. So you might change the position of toilet, everything here and there. But because this is just a diagram, you don't need to concern about whether you're going to change the plan or not, because as long as you can determine, you can decide how many WC that you want to use, how many basin that you're going to use, then you can straight away produce the diagram. Okay, so basically this is from different building lah. So this is not for, this diagram is not for this building, it's for a different building. But this is how it looks like from the diagram, because from this plan you can see that from the toilet it goes to the manhole, okay, and from one manhole to another manhole. So from the diagram it looks something like this. So just imagine that this is the first toilet, so everything goes to the first manhole, and then from the first manhole to another manhole. So because there is a gradient between the pipes, okay, from the appliances to the disposal point, so you need to show the grade, but you don't really have to know exactly what the gradient is, but you need to show from the diagram that there's some kind of gradient. Okay, so it's not really a horizontal straight line, so you need to be tilted a bit like this, and then because of that, the manhole or the inspection chamber gets deeper and deeper from one manhole to another. It gets deeper and deeper, okay, until the end. But in this example, basically there's a septic tank. Basically the waste disposal ends at the septic tank, okay. But in your case, basically because your building is located at an urban area, right? So I believe there's a main sewer line, so you just need to connect to the main sewer line, and don't think maybe you need to provide only one inspection chamber before the waste is discharged, okay, connected to the sewer line, but only one. Okay, so you need to provide all this line here, the diagram from the appliances, everything, and everything connects to maybe one inspection chamber or manhole here, for example, and the rest straight away from the appliance connect to the from the discharge pipe connects to that inspection chamber, and then after that inspection chamber, straight away you can just draw like an arrow to indicate that it goes to the main sewer line. Okay. Right. So I'm going to have tutorial on this afterwards. Okay. So now let's look at the sewage treatment. Okay. Like I mentioned earlier, as an architect, you need to be concerned more on the sanitary system, okay, than the sewage treatment. But you need to understand how it works. Okay, you need to get the bigger picture of how it works. But in terms of your role as an architect, basically this is not your job, lah. So this is the job as for the civil engineer. Okay, so in sewage treatment, basically there are two types. There are two main types of sewage treatment, whether it's individual or communal. So individual, basically, like I mentioned, if you are designing a bungalow and if your building or the bungalow is located far from other buildings or located at rural area, then most probably you're going to use this septic tank. Okay, So all the waste treatment will be done at the septic tank and then discharged to the ground or to the nearest river or stream. Okay, and another type is for communal. Communal is it's like treatment for if you have so many houses, or if it is a development, new development. So basically, the treatment is for a lot of buildings. Okay, not for individual building, but for a lot of buildings. Okay, a lot of people, like thousands of people. Then it depends. If the community is not so big, maybe like a few hundred, then it is still using septic tank. We call it a communal septic tank. Or for example, like if there is a boarding school or institution, but not so big, maybe not a university, just a boarding school located maybe in rural area, then it is still using septic tank, okay, because there's no sewer line to connect to. So everything will be done at the premise itself. But if the community, if the development is big, it's like a residential development, mixed development, a lot of houses, right? And then the number of people in that development is like thousands, 1,000 or few thousand of people. Then you need to have the sewage treatment plan or STP. Okay. Okay. So sewerage treatment system. So basically, this is what we call a sewerage system. So the system includes like piping, everything, and the plant and so on. But if it's only septic tank, then we don't really call it a system because it's quite straightforward. From the house or from the building, straight away goes to the tank, and that's it. Okay, but for sewage system, normally we use sewage treatment plant, and there are different kind of treatment plant available. Okay. Okay, this is the evaluation of sewerage system in Malaysia lah. All right. So from before 1950s until now. Okay. So previously there's no proper toilet. Okay. If you live next to a shore, okay, near the sea, okay, if you have like a floating house like this, and you can do your business straight away, will be we drop into the sea, okay, into the water, and that's it. Or maybe on the beach, or maybe like some people that have like in some area they have like a proper space, okay, proper room for a toilet, but there's no water supply, so the water need to be carried into the toilet. Okay, and then between 1950s, the toilet is, especially if you go to the village, maybe you can still see this kind of toilet. Okay, it's like a toilet cubicle with a squat toilet inside, and but the system is pour flush, meaning that you have to carry water from outside or maybe inside the cubicle itself. And then you need to fill a bucket, and then after you have done your business, you need to flush. Right? But everything is actually inside the cubicle itself. Okay, so the waste is actually released on the ground directly below the toilet. Okay, you can imagine the smell or whatever. And then in 1960s, we start using the septic tank, okay, for houses and for buildings. Okay, and then 1970s, a bigger tank, which is called Imhoff tank, especially for housing developments. Okay, early housing developments, we use Imhoff tanks. And then 1980s, when we start to have bigger residential development, mixed development, then we use, or OP is oxidation pond, AL is aerated lagoon. Okay, they are more or less the same. We'll show the difference between the two afterwards. Near my house, we still use this kind of system. You can see, right? Maybe near your house also you can see this kind of pond, right? And then 1990s and 2000, there are more complicated facilities like activated sludge, biological filters, and nowadays we use fully mechanized plants. Right? So as you can see from the objective of this different system, okay, between the 1950s, 1960s, the objective is just to address public health, right? From 70s to 90s to address river pollution, okay, and then 2000 until present is to address the environment. Okay, septic tank is a structure constructed underground for sewage treatment. Okay, installed with inlet, outlet, and vent pipe. Septic tank may have 1, 2, or 3 chambers, but 2 chambers is widely used, especially for a house. If the building is bigger, like I said, if it's something like a boarding school or something, then you can see a bigger septic tank. Suspended solid settle at the base of the tank, allowing more. I think I'm just going to show you the video of how it works. Okay, so basically the water released from the septic tank is slightly clean, even though it's not 100% clean. Okay, so as you can see here, septic tank treats only a portion of the sludge in the sewage, about 50% efficiency. So meaning that it is not very clean, but if you channel the water, okay, to the ground, then it can be some kind of become some kind of fertilizer to the plants, right? Something like that. Okay, so this is how a modern septic tank looks like. Okay. Layers in septic tank. I think I'll leave it to you to read afterwards. Okay, after once in a while, actually you need to dislodge the septic tank because there is a maximum volume of septic tank that can be stored. Okay, so we cannot leave the septic tank to be to use until its fullest. So you need to dislodge, or you need to take out some of the sludge inside the tank. Okay, typical septic tank arrangement. So this is a continuation from the layout plan, sanitary layout plan that I've shown you earlier. So earlier, I've only shown until the manhole, right? And then after the last manhole, either it goes to the main sewer line, or if it connects to the septic tank, then this is how it looks like. So just imagine that this is the manhole, and then from the manhole, it gets to the septic tank. And then from the septic tank, it goes to the, so OA is basically just the pipes that discharge the treated water into the ground, or in some cases, it is discharged to the stream or river if there's a river nearby. Okay, if not, then it's just discharged to the ground, and the water can become some kind of fertilizer to the plants, right? Okay, so now let's look at the sewerage system. As I mentioned earlier, sewerage system is a network of underground sewer pipes, pump station, sewage treatment plant, or wastewater treatment plant, and sludge treatment facilities that treat the sewage before discharge. Okay. In Malaysia, the company that deals with sewerage system is mainly IWK, Indah Water Consortium, even though they don't really manage 100% of the sewerage services in Malaysia. Okay, as you can see, it's only 88 out of 144 local authorities in Malaysia. Okay, but in cities normally, the IWK would provide their services in the cities. Okay, okay, this is the overall system. Okay, the overall view of the sewerage system. Okay, it starts with the inspection chamber in the house. Okay, so the sanitary system stops here. Okay, from the discharge pipe, it goes to the inspection chamber or the manhole. But this one is more like this inspection chamber. And from the inspection chamber, it goes to through the private sewage pipeline, meaning that from your house to the main sewer line. And then from the private sewerage pipeline, it goes to the public sewerage pipeline. You can see that the pipe is bigger. And then at certain intervals, there would be public manhole for people from IWK to check, okay, to do inspection, to clean or whatever I've mentioned earlier. And then from the from the sewerage pipeline, it goes to the treatment facilities. Okay, so basically this whole thing is the treatment facilities, the sewerage treatment plant. The screen is just like a fencing lah, so people cannot enter because it's very dangerous if you get into the treatment plant. F is aeration tank, depending on the system that it is using. I mean the area is using, whether it's aeration tank, but the overall treatment plant would have this aeration tank. F, G is clarifier, H sludge digesters, and finally I, like I said, if there is a nearby river or stream, then the water will be channeled to the river, or if not, then it's just exposed into the ground, right? Okay, so the sanitary sewer or sewage pipeline basically carries the sewage from the house to the treatment facility. As I mentioned, manholes are placed at certain location along the sewer line. Okay, this is the kind of camera or CCTV that is used inside the sewer line. So sometimes I think something you might have seen this. So maintenance people working inside the sewer line, they usually open the manhole cover and they inserted like a cable inside, right? So basically at the end of the cable is this CCTV camera to do the inspection. Okay, let's look at this video that explains the overall how the wastewater treatment is done.
It's a topic we'd rather not think about. Where does last night's dinner go when we flush it down the drain? While you may already be grossed out just thinking about it, this question leads way to a significant subset of civil engineering and a massive amount of public funding. Just like all dogs go to heaven, all drains in a city lead to a wastewater treatment plant where that wastewater gets turned back into water that we can drink. Now, you may be thinking that you'd rather just let bygones be bygones and not think about this nasty part of real life. But here's the thing. Chances are you've drunk water that was waste at some point, so you might want to take some time to understand this engineering process that makes dirty water clean. Here's where it starts. The toilet. Once you're done doing your business and flush that magical handle, your waste ends up at the inlet of one pretty interesting place, a wastewater treatment plant. Why is this place so interesting? Because it takes arguably one of the most disgusting substances in the world and turns it back into something that is essential to all life. Flushing just your toilet at halftime may not seem like a big deal, but when you couple it with thousands, if not millions, of others doing the same, it can result in some pretty high sewage flow rates. New York City has an array of 14 wastewater treatment plants that handle a combined 1.3 billion gallons of wastewater daily. That's enough wastewater to fill the Dead Sea with pure sewage in just 8 years. And that's just New York City. There are an estimated 14,748 treatment plants in the U.S. alone that 76% of the USA's population relies on, according to the American Society of Civil Engineers. Understanding wastewater is crucial to understanding the critical infrastructure needed to support and vortex grit chambers, which all accomplish the same task using It's a topic we'd rather not think about. Where does last be raped at certain intervals depending upon the flow rates of the water treatment plant, although some older plants will still have more manual removal processes. Whatever is removed is then sent off to your average landfill or solid waste handling facility. Or, in the case of unusual items such as guns, they're sent off to the evidence locker in a police station to be investigated. Next up is the grit chamber. Grit chambers are the next steps in the pretreatment process following bar screens. Since these bars don't catch everything, larger particles called grit still need to be removed from the sewage as it is made even more homogeneous. As the sewage flows into the grit chamber, the velocity of the rather viscous sewage is adjusted to allow for particles of sand and rock to settle out. This is needed because these particles can't be removed using chemicals, and they could potentially clog or destroy pumps later on in the process. There are three types of these chambers: horizontal grit chambers, aerated grit chambers, and vortex grit chambers. Accomplish the same task using slightly different methods. Following the grit chambers, the sewage will move on to the primary treatment process, which starts with a large basin called a primary clarifier. Primary clarifiers and clarifiers in general function on the principle of settling velocity. This term can be defined simply as the speed at which a particle settles. For wastewater being pumped into clarifiers, it's important that the flow rate of the water being pumped in doesn't exceed the settling velocity of the particles trying to be removed. In order to accomplish this, engineers will vary the size and number of primary clarifiers in accordance with the plant's permitted sewage flow rate. This ensures that at varying flow levels, solids can settle out of primary clarifiers to the correct quantities. At this step in the process, the slightly treated wastewater, which is referred to as effluent, is free of solids larger than 10 micrometers and should be all organic matter, which will be treated further. The top layer of the clarified water flows over a weir wall and into the next basin process called the aeration basin. Now begins the process of secondary treatment, the sole focus of which is to significantly degrade the biological content of the sewage. In many cases, this process starts in aeration basins. Effluent flows into the aeration basins, at the bottom of which are hundreds, if not thousands, of tiny air blowers that create bubbles through the water. The water is pumped into this tank along with something called return activated sludge. You can think of return activated sludge as a bunch of happy little bacteria that get to eat their favorite foods all day long. This introduction of significant amounts of bacteria along with the massive amounts of from the bubblers creates an environment perfect for the process of aerobic digestion. Summarized simply, it's the breakdown of organic matter along with the use of excess oxygen. Some older plants will add in another step before aeration basins referred to as biofilters or trickling filters. Found in many older plants, these filters essentially trickle the effluent over a medium like stone or plastic and for a film of bacteria to chow down on any organic matter in the water. This step is largely not used in newer plants due to more efficient and effective modern processes, but for plants with basins already installed, many still use them because they only benefit the treatment process in most cases. Following aeration basins, the effluent along with much of the sludge is pumped into a secondary filter or clarifier, where some of the sludge is removed and pumped back into the aeration basins as the return activated sludge. Further settling of larger particles is also accomplished in these basins, as it is the final step of the process that will remove solids and larger biological matter. Water flows out of secondary clarifiers over a nearly identical weir wall to the primary clarifiers and moves on to the disinfection process. At this point, 85% of all organic matter is removed from the water, and the effluent should be safe to drink in most cases, although you probably wouldn't want to. Disinfection is the final step of the process and is usually accomplished in one of three ways, either through chlorine, ozone, or ultraviolet disinfection. Each process has its benefits and drawbacks, with each being used commonly throughout the wastewater treatment process across the world. Chlorine disinfects the water through chemical disinfection. Chlorine, which you can think of as concentrated bleach, is added to the effluent here to kill off any remaining bacteria and organisms still living in the water. When chlorine is added to kill off the bacteria, it then has to be removed before it can be discharged, as to not kill off anything in the discharge location. After this, the water is safe enough to discharge into a stream or lake. Ozone disinfection is another method of disinfection that involves pumping an electrical current through the water that causes oxygen molecules, O2, to disassociate and combine with a free oxygen molecule, forming O3, known as ozone. Ozone is an incredibly strong oxidant and causes microbes' cell walls to leak, rapid cell decomposition, and overall damage to cells. In other words, it kills off bacteria. The last common method uses ultraviolet light to scramble bacteria's DNA so that they cannot multiply. In UV disinfection, the bacteria in the water aren't killed, rather they're sterilized, rendering them harmless. If you were to ingest water with living microbes immediately following UV treatment, any harmful bacteria would be unable to multiply or render your body damage. Engineers choose between these methods based on a variety of factors such as flow rates, cost, and location of discharge, which brings us to the final step, effluent release. Effluent release exists in one of two forms. In most cases, the now treated water is released back into a stream or lake or other water source. In rare cases, usually in areas where water is scarce, the effluent discharge from a wastewater treatment plant can be discharged into another treatment plant directly where it will be treated further for consumption. This is referred to as full cycle water reuse. From a chemical perspective, the final drinking water is the same as normal treated water that flows through your pipes now. But due to the connotation of your drinking water being sewage just days before, this treatment process is normally shied away from or not heavily publicized. The entire process of wastewater treatment takes on average 24 to 36 hours from when a drop of water enters to when it leaves. Each wastewater plant will receive a permit for flow rates, chemical levels, and effluent quality, among other things, from the EPA that outlines the necessary treatment for a plant. Wastewater plant operators will make adjustments to a plant's operation and constantly measure levels to ensure proper discharge and proper treatment. Without these operators and the dirty job that they do around the clock, our sewage would always stay sewage, and sanitation in modern cities would be much, much worse. Wastewater treatment is an essential dirty job, and you can thank the 14,748 treatment plants in the U.S. alone for not having to worry about what happens when you flush.
Okay. So basically, these are the system of sewage treatment plant. Okay, there are two types of system: mechanical and non-mechanical. So non-mechanical is oxidation pond and Imhoff tanks. Mechanical is basically 6 different system there, but I only indicated 3 types here in the slides. I guess you can just read through later on, because like I mentioned, your role as an architect, you don't really need to, this is just for knowledge, right? So you don't really need to choose which type of system to use and so on. So this is the role of an engineer. And I think our lecture has gone too long now. So I think I better stop now and proceed with the tutorial. Okay, so as I mentioned earlier, tutorial is going to be done in mass, meaning that so both my group and Mr. Rizal's group will be here. Okay, because I'm going to show you how you can come up with the sanitary layout plan and diagram. Right. All right. I think that's all for today for this lecture. Okay. And for the tutorial, can we start at 10:55? Okay. Is it okay?
We studied.
Yeah.
So today you are going to give the tutorial.
Yes, for everyone.
For everyone. So, which means I will not see my student for this week.
For this, because I believe like most of you still don't have a finalized plan. Okay, like last week when I look at the students' work, they mentioned that they don't have a finalized plan, and even their building, they don't have toilet yet at the, in the building, right?
Okay.
So maybe nothing much can be done for the other parts. I think let me just show you the diagram, how we can produce the diagram. Okay.
Okay, I just want to inform my student. Okay, for those who are under my group, okay, can you please send me the schematic diagram for cold and hot water supply system? Yeah, so I will give a comment on that. Just send me through MS Team lah, yeah. But for today, just learn from Mr. Adit on how to do the design for a sewerage system.
Okay, so we will start at I think maybe just make it at 11. Sorry. Is it okay? We make it at 11. So please stand by some papers, a piece of papers, and your pen or pencil, because you need to draw. And yeah, so I hope you can straight away do your sanitary diagram for your building. And I think it is better if you already have your plan, okay, for your final project, and you can just scribble on your plan. If possible, maybe you take a butter paper and then you just trace on your plan. All right, I'll see you at 11 here. Okay, so right now you can take a break, 10 minutes break, right? So make sure you bring pen and paper. Okay, thank you. I'll see you later.